Yeah, see here. So at this particular point, at this particular if I draw a line that connecting all these data points, so these all are my data points, right? So these all are my data points. Okay, so if I connect all these data points, it looks somewhat like this. See, the data points are very symmetric. See, when you draw a line, okay, so okay, so okay, how can I find what mean for it? So 2 plus 2.4, yeah. Okay, so here and here, guys, can you find out the mean value for it? Can you find out mean value for at what particular salary the mean value exists, right? So can you find out mean for it, this particular salary? At what particular average salary the average salary of people were getting in XYZ company? Guys, can you find out the mean for it? Can anyone do that for me? You just need to add all the salaries and divide it by, yeah, so is it 4? Is it 4? So 2 plus 3.5 plus 4 plus 4.5 plus 6 by 1 2 3 4 5, is that a 4? Just check it. Yeah, so 2 plus 4 6, no, so this is my data point, right? So the here also data point is there at 2.5 and as well as 4.5. You should add those two also. 2.5 plus 4.5, it is 7. Yeah, so is it 3? Guys, are you all trying? Yes. So it was, yeah, it was 3.7, right? So somewhere 3.7, this was my okay, okay, guys, consider it as a 3. Consider it as a 3, not 2.5. Consider it as 3 because this point exactly in between 2 and 4, right? So consider this point as 3 and this point as 5. So you have to do 2 plus 3 plus 4 plus 5 plus 6 by 2 plus 4. Okay, let me do it, guys. So it was basically 2 plus 4, sorry, 3 plus 4 plus 5 plus 6 divided by, so how many data points were there? 1 2 3 4 5, right? So 20 divided by 5, so yeah, so that was basically 4, right? So exactly here, right? So see here, guys, yeah, see here, as you can observe here, the mean for this particular for this particular data point is 4, right? So the mean for this particular data point is 4, right? So when you draw a line here, yeah, so this was my mean. See here, guys, if you can observe this diagram, so whatever the diagram that you're seeing here is symmetrical with the line, with one particular line that you're drawing through the mean, right? So this was my mean, right? So for at 4 the mean value was there. So if you draw a perpendicular line at mean value, if you draw a perpendicular line to mean value, right? So your diagram is symmetrical, right? So this part and as well as this part, so both are same. Guys, are you able to understand? Yeah. So this was my mean, this was my mean, right? So when you draw a line, a perpendicular line to mean, from mean through mean, so the diagram left hand side of this particular line is equal to right hand side, right? So this particular, yeah, so we can think of the mean is balancing both left hand side and as well as right hand side, right? So this is what exactly we call as normal distribution. Normal distribution, guys, I remember this name, normal distribution. So normal distribution or Gaussian distribution, or we can think of there is bell curve shaped distribution, right? So what do you mean by distribution, guys? Can anyone let me know what is distribution? What is distribution basically? You can give any answer. So what exactly the distribution is? What is distribution? Equal part? No, no. So the distribution is nothing but, guys, the data, how my data points are, right? So as we can see in the last class, right? So we have seen in the last class, yeah. So yeah, see here. So this was my data distribution, right? So 200, 150, 160, 160, 140. So this was my distribution. See, in one column, how my data got distributed. In this cement price, how my data got distributed, right? So it's all about data points, right? So it's all about data points, right? So this distribution is nothing but, the distribution is nothing but how my values are in one particular feature or one particular column. Even that could be in labeled also. So when you think in label data, label column or label feature, how my data was, right? So is it normally distributed? So normally distributed is something like this one, the diagram just now I shown you, right? So this was my normal distribution. So where I have it, if I draw a one particular vertical line through me, so the left side data is equal to the right side data, right? See guys, see, yeah, okay. So what is the highest salary range, guys, here? What is the highest salary in this case? What is the highest salary in this example? Yeah, so it was $6,000 per month, right? Consider, guys, consider, if I have, one person is having, mm, 12,000, or let me take 10,000. One person is having 10,000. So okay, so there are something like, um, yeah, so there are 100 people, there are 100 people, uh, there are 100 people, let me take not even 100, okay, mm, okay, see guys, there are few people, let me take it as 100 people or 200 people who are getting $10,000 per month. So if I draw a point for them, so it will be something around like this. Let me take it here, let me take it here, let me take it here. Okay, so there are, this was my $10,000, this was my $10,000, and the number of people were around like not even 100. So let me take it as 60 or 70 people, right? So if I draw a line or curve, if I draw one particular curve, that is getting through each and every data point. So now okay, if I add, see guys, just try to analyze. So earlierly, what was the mean value, guys? Earlierly, what was the mean? What was the mean? Yeah, it was 4, right? So now check, if I add 10, where will be my mean? If I add 10, where will be my mean? Okay, so if I add 10, where will be my mean? It is 6, right? So now here the mean is something. Okay, so let me draw here. Okay, so let me remove this. Okay, so guys, so for this for this particular reason, I was actually planning to buy that. So maybe within next week I'm going to have that. So because there are a lot many things that I need to write on this particular thing, because with this laptop touchpad I cannot write each and every calculation, and even if I it is very difficult to draw even this particular diagram, right? So that's why kind of uh, what we can say, so there is no frequency in the classes, right? So if I do have that, so I can basically explain each and everything with more in, like, it will be like class environment, right? So where you can all of you sit in the class and I can explain you on the board, right? So I want that thing to be in online platform, right? So that's the reason I just want to have that. Okay, so see here guys, if I draw, oops, yeah, so let me draw it here. Yeah, so now see guys, my diagram will look like, so if I had, and now the mean is it 6 or 5? Is it 6 or 5? So 20 plus 30 by 5. 1 2 3 4 5 6. Yeah, it was 5, right? So basically 30 by 6, right? So now my mean will be like here. Okay, so yeah, guys, you can observe the diagram. Yeah, okay, so fine. Okay. Mm, yeah, see here guys, if you can observe, so earlierly my mean is at 4, but now my mean got shifted to 6, right? So somewhere around like here, right? So here the mean is here right now, right? So the mean is here. And guys, what is the median then? What is the median in this case? What is the median in this case? What is the median? Guys, quickly, in this case, what was the median? This case, is it 4 in this case? uh when you arrange them, so let me take that points case. So yeah, so let me take here at my data point. So those are 2 3 4 5 6. What happened? Yeah, 6, right? So yeah, so this was my data point, right? So to when you arrange them in a descending or ascending order, the median will be 4, the middle value, right? So here the mean is 4, and as well as the median is also 4, right? So in this case, so let me write it here. Yeah, so mean is 4 comma median also 4. Okay, yeah. So now see here guys, the frequencies must be used. uh, what this one you're asking, the right side on on y-axis, is this normal distribution curve? Yes, that's what only I'm teaching. Okay. Yeah. See here, guys. See here. If I add 10,000 per month, if I add $10,000 per month to this particular data point, my mean got shifted to 6. Now the mean is here. So what is the median, guys? What is the median if I add 10? What is the median if I add 10? Yeah, okay, mean is 5. Yeah, so somewhere around like here. That's so let me take it as, yeah, so mean is something like this. Mean is here. So now what is the median? 4.5, right? So 4.5. Is it here? Is it here? Right, so it was here. Right, so 4.5. And yeah, so see guys, if I add, so you have added only 10K per month. If I add 20K per month, if I add 20K per month, $20,000 per month, mean will be somewhere around like here, right? So even though if I add instead of 10K, if I add 20K, mean will be here. And where is the median, guys? Where will be the median? Where will be the median if I add 20K instead of 10K? If I add 20K instead of 10K, so where will be my median? So is it 5 or 4.5? Same, yeah, it will be on 4.5 only, right? So it will be on 4.5, right? See guys, see here guys, when you observe the curve, the curve is bending towards its right side. See, now here, earlierly it was stopped here only, it has stopped here only, right? So like this, but here in this case it is keep on going, right? So this is called positively skewed distribution, right? So positively skewed. So why it was positively skewed? In a sense, see here, so are you 10 or 20? So 20 instead of 10, I'm adding 20K. Okay, see here guys, see here. So my curve has bended towards its right side. So this is what exactly called as positive skewed distribution, right? So positive skewed distribution. So why it is positive skewed distribution is, see, you have data points like this, right? So when you add huge number, 10 or 20, right? So 10 or 20, if you add a huge number, right? So this particular number, this small higher number is dominating this larger section, right? See guys, this particular smaller 20 value is dominating this particular section, because earlierly the mean was 4, right? So earlierly the mean was 4, but now the mean got shifted to somewhere around like, if you add 20, it got shifted to somewhere else like 7 or 8, right? So this is what exactly called as the positive skewed distribution, right? So now yeah, so in this case guys, let me draw another here. Yeah, so now forget about this thing, 10 and 20. Yeah, so so forget about this 10 and 20. Now you have added 0.1, and 0.2. Consider 0.1, guys. For this particular data points, you have added 0.1, 2, 3, 4, 5, 6. You have added 0.1 salary. Now what was the mean, guys? What was the mean if you add 0.1? Guys, you have added 0.1. So what will be the mean now in this case? Guys, you have added 0.1, right? Now in this case, what will be the mean? Okay, so it was 3.35, right? So 3.35. So okay, so yeah, so add 0.01, add 0.01. So instead of 0.1, add 0.0 uh, 0 01. Add 0.01. Guys, add 0.01. 0.01. Is that mean? 20.00, is that mean? So remove this one. Don't consider this 10 and 20. Just to this particular data point, 2, 3, 4, 5, 6. Add only 0.01. Just tell me what was the mean. This 2K salary, 2K $1,000 per month, and $3,000 per month, $4,000 per month. So add 0.01. So see guys, compared to this value and this value, which is small, guys? Which is small? So it is very, very small, right? So it was very, very small. Now when you have a lower the here in previous case, this was huge number, right? So compared to this value, this was huge number, right? So in this case, I'm adding very low number. I'm adding very low number. For that, for that's the reason my mean will be shifted towards left. Here the mean got shifted to right, right? So if I add 20K, my mean got shifted to right. But here in this case, my mean will be shifted to left, right? So yeah, so 3.3 and something like that, right? So my mean is shifting towards left. Now the diagram looks like this. Okay, yeah, so the diagram looks like this. Okay, see guys, so this is called as negatively skewed distribution. So negatively skewed distribution, right? So the my data points are, guys, my by considering these three scenarios, consider, let me draw. This is one diagram, this is two, and this is three, right? So if I had lower number, lower, very far away number, right? So my mean got shifted to left, right? So in this case, the mean will be something around like this, and the median will be same. Median will be almost like here, right? So I just opposite of this one, right? So if I add 20, so the median is somewhere around this. The actual mean was at this particular 4, but you got median as this something around 4.5 or something like that. But mean will be here, right? So in this 1, 2, 3, in this 3 diagram, how many diagrams are having outliers and how many diagrams are having not having any outliers? Just guys, give your answers in the chat. So in these three diagrams, what are the diagrams, what are the data that having outliers, and what are the diagram? Just consider these three graphs.
Two, third one and the first one.
Yeah, so the first one and third one is having outlier. So the mean will reduce if outlier is low, medium will be same. Yes, absolutely. And vice versa also, Fatima. Right? So when you have a low value, when you have extremely low value than actual data points, the mean will shifted towards left. When you have extremely high value, I mean high outlier, right? So outlier can be anything, right? So outlier can be even low value and outlier can even be high value, right? So when you have extremely high values in your data point, so this was my data points, these are the actual data points, right? So uh, so these are the actual data point. So if I have extreme outlier, if I have extreme high value as a 20, my mean got shifted towards right, right? So if I have extreme low value as outlier, my mean got shifted to left, right? So two diagrams are with outliers. You're saying number two diagram is with outliers or else? Fatima, what are the diagram that containing outliers? Which diagrams? Yeah, so 1 and 3 diagrams are containing outliers because my mean was not it. The see, if you have a if you don't have outliers in your data, even though if you have outliers, but that is not affecting that your actual data point. So if you have outliers also, if you have outliers also, that is not affecting your actual data point, that would be totally fine. But when you have an outlier but that is dominating the actual data points, then that is a problem, right? So if you have a outliers, right, so it is not, if it is not affecting actual data point, that would be totally fine. But if you have an outlier that is affecting the actual data points, and that would be problem, right? So here the if you draw a line between mean, right? So if you draw a vertical line through mean, the shape will not be symmetric, right? So the shape will not be symmetric. Okay, so when you draw a vertical line, so when you draw a vertical line through its mean, right? So the shape will not be symmetric or the shape will not be same. But here whereas whereas the data distributed normally, if the data distributed normally, when you draw a vertical line through its mean, right? So the diagram will the diagram will be same as left hand side to right hand side, right? So is this concept clear, guys? Guys, is this concept clear, everyone?
Sir,
Yeah, it just I given just a basic idea of, yeah. So a high outlier will increase both mean and median, but the mean will increases more than median. Yeah, yes, absolutely right. So mean will robust to outliers. I mean, what we can say, yeah. So mean is actually what you can think of a median. Okay, so let me say like this. See, even though if you have outliers in the data, that's what we see in the last class, right? So when we have to use mean and median, right? So when you have outliers in the data, see, here 40k is, here 40k is my outlier, so that's why I've used median here, right? So mean will affect a lot when you have outliers in the data, but median, we can see hardly deviation or hardly change in the in the median, right? So when you have outliers in the data, is this clear, guys, concept?
yes, sir.
Okay, give me a second, guys. Okay, so let me go to the theoretical part that we have for today, so then we can, yeah. So now see here, guys. So the central tendency will tell us where the actual data is the lies within the range, right? So the tendency of the values of a random variable to cluster around its mean, median or mode, right? See here, as you can observe here, see, this was my normal distribution, right? So normal distribution or Gaussian distribution, both are same. So when you have a normal distribution, see, Here in this normal distribution case, mean and median mode both are same, both are at one particular point, right? So both are at one particular point, right? So when you have a positively skewed distribution, so if you have extreme high values as an outlier, see the mean has shifted towards right? So now the curve has bent towards its right? So earlierly the curve was like this in case of normal, but when you have a extreme high outliers, extreme huge values of outliers, the median is somewhat here. The median is somewhat here, but mean is shifted very, in a drastical way, right? So the mean got shifted very far from the actual mean, right? So even in the negatively skewed, so this was my positively skewed, and when it comes to negatively skewed, the mean has shifted towards its the negative side, right? So here the mean has shifted the positive way, because this was my 0th point, right? So this was my 0th point, and when you when you going towards right side of x-axis direction, the values will be high, right? So 0, 1, 2, 3, 4, 5, right? So in case of positively skewed, the mean is shifted towards the positive side. In case of negatively skewed distribution, the mean is shifted towards its negative, right? So see here, so my 0 point here, 0 point is here, 1, 2, 3, 4, 5. So mean was here, but actual mean was here, but my mean got shifted towards its left side, right? So when you do have the outliers, the extreme low outliers in the data, extreme high outliers in the data. Is this two concept clear, guys? Actually, I've made three concepts. So when you have a normal distribution where there is no outliers in the data, and the second case is when you have extremely high outlier, right? So extremely high values of outliers and extremely low values of outlier, right? So when we go further, see here, yeah, see here, guys. So these are my data points: 2, 4, 4, 5, 6, 10, right? So when you do mean for it, when you do the actual mean was the actual mean, guys, can you just tell me what is the actual mean for this? 2 plus 4, 6, 10, 15, 21, and 31. So 31 divided by 6. What is 31 divided by 6, guys? What is 31 divided by 6?
5.166667.
Yeah, so it was like 5.16. Let me take, right? So now median, what is the median, guys? What is the median in this case? So when you add ascending or descending order, so this was my ascending order. So middle values are 4 comma 5. So 4 plus 5 divided by 2. So 9 by 2. What is the median? 9 by 2.
4.5.
Yeah, so it was 4.5, right? So 4.5. Now, and the mode is something, don't consider mode, because a mode we obviously use for categorical data, right? So it is like string formatted.
So
Now,
what is two, right?
yeah, so in this case the mode is 4. Yeah, see here, guys, positively skewness is nothing but, see, if I had 1000, if I add 1000 to this particular data point, so these are my actual data point, but I have added 1000 to it. Now the mean earlierly was, yeah, so earlierly it was 31 by 6. Now if I add 1000, so it was like something around like 31 plus 1000, it is 1031 divided by 7, right? So 1, 2, 3, 4, 5, 6, 7. See, guys, so what is the mean in this case? What is the value of 1031 divided by 7?
146.714.
Yeah, so it was 146.7, right? So here
One
earlierly the mean was 5.16. Now it was 146.7, right? So the mean has we can observe a huge change in mean, huge change in mean, right? So that's why the mean is shifted towards its right side, because see, earlier it was 5.16, right? So when you think of here, so consider here is a 5.6 5.16. Now the mean is something around like this, where we have 146.7. now what is the median, guys? What is the median? What is the median in this case? What is the median? It was
5.
yeah, it was 5, because left side 3 values and right side 3 values, so it was 5, right? So the median median was 5. What is the earlier median, guys? It
I
was,
was wrong in me.
yeah, okay, no worries, so it was totally fine. So yeah, so earlier in earlier case the median was 4.5, now it was 5, right? So there is only 0.5 change in median. So that's why, see here, when you observe here, so in the normal distribution case, the mean, median, mode are equal, but in positively skewed, the median is somewhere around like this, but mean is very far, very huge, right? So there is just a slight deviation from the actual mean. If you have if you add a huge value of outliers in your data, right? So when it comes to negative, when it comes to negative, so yeah, so let me take another example, because here I have already taken 244, so there is no negative, there is no less value than 2. If I add 1 will be the less value, but see here, in this case the mean will be, 48. Is the mean will be 48, guys? So 50 plus 50, 100, 240 by 5. What is 240 by 5, guys? 240 by 5.
48.
Yeah, so here the mean was 48. Now, so if I add this low numbers, in the earlier case I have added only this one higher number, but if I add this particular low wages, low numbers, see, the actual data points are around like 50, 40, something like that. But if I add this low numbers such as 213, now what is the mean, guys? What is the mean? It was 246 by
30.7.
8, so it was 31. See, 48 and 31, so
30.
around like 9 8, so there are 9 9 18 17 difference from actual mean to the mean that you got when you have lesser, I mean huge, less value, or the minimum values of outliers. That means the lesser values of outliers, right? So is this concept clear, guys? Negatively skewness and positively skewness, everyone? Yeah, so it's just a distribution of data, guys, right? So it's just a distribution of data, right? So at each point, what was my frequency of occurrence, right? So at this particular point, my number of people were this much, right? So at this particular point, my number of people were this much, right? So actually at mean value, my data points are very high, right? So when it comes to a normal distribution curve, at mean value, at mean value, the number of people were more, right? So that's what basically it means, right? So yeah, so that is what basically different types of distributions we have in our data sets, right? So let me go back to the standard deviation and variance, right? See, guys, let me explain what exactly the variance is. So variance is nothing but, see here, guys, if I draw mean to this particular data points, I got mean as 5.16, right? See, guys, when you observe the actual data points are somewhat closer to my mean, right? So here the actual data points are we can think of somewhat closer to mean, right? So 2 to 5 there is 3 difference, and 4 to 5 there is 1 difference, 4 to 5 1 difference, and 5 to 5 to 5 there is 0.16 difference, difference, and 6 to 5 there is 1. and 10 to 5 it is like 5 different, right? So we can observe some kind of closeness within the data, right? So variance will tell that, right? So variance will tell, right? So variance will tell how my data points are distributed, are they really close to each other, or are they far from are they far away from each other, right? So the variance will tell how my data points were distributed, are they data points are really close to each other, or else is there any huge gap between the data points, right? See guys, let me give you an example, see here, see. Okay, so let me come to this point. Is this clear guys? Variance, what is the need of variance? Just a definition part. So basically it will tell how close your values are, how far your data points or data values are in a data set. Guys, is this clear, the variance part?
Sir.
Yes.
Yeah, so here I'll explain the example so that you can easily understand, right? So the expectation of a squared deviation of a random variable of its mean, right? So the expectation of squared deviation, it is actually the formula, no worry about it. So it measures how far a set of numbers are spread out from their average value, right? So this is what the definition of variance, right? So it is basically used to measure, how far a set of numbers are nothing but the data points, right? So the data point, so how far the set of numbers are spread out from their average value. So that's what basically variance tell us. So variance is guys, what is the symbol for mean? What is the symbol for mean? So mean is nothing but this one guys, this mu symbol. I hope everyone know this particular symbol, mu. Is this guys, everyone know this one, the mean, the mu symbol? Okay, so this is what the representation, the mathematical representation of mean, right? So mu symbol. So mean symbol. X bar. See guys, we can even think of X bar. X bar is also mean. See, I hope you can see this one. So see here guys, the first one, mu. So this mu is nothing but we can think of it is a mean. So we have not gotten to the actual core concepts of math. So where we can also use this symbol as a population mean. Okay, just think that this is a symbol to represent mean. Okay, so now variance is nothing but sigma. Variance is nothing but sigma square. Guys, I hope everyone know what is the symbol of sigma. So square sigma square. So this is guys, so as you can observe here, so this is variance, right? So we will represent variance in mathematical form as sigma square, right? So how you can actually calculate variance? So variance will tell us how the data points are they actually away from the mean, right? So see, if I have the mean like this, right? So I want to calculate the variance of this particular data point, right? So I want to actually find out the variance of this particular data because I know mean, but I want to figure it out whether how close they are from the mean or how they far away from the mean, right? So I want to just have a clarity on the closeness of the data from the mean or the awareness of the data from the mean, right? So that's what I want to find out, right? So what is that? The formula for finding the variance is summation of all. We can think of this sigma. Is this sigma, guys? just think it as summation. So we can even call it as is it sigma summation? Yeah, so it was summation symbol, guys. So even some people call it as sigma only, right? So the summation of x minus mu whole square divided by n, right? So I'll tell you guys how we can actually find out variance for it. So consider this is my data point, right? So this is my data point, and the mean for this particular data points is 40 divided by 5, and that is 8, right? So the mean is 8. Now I want to calculate the variance. So what is the formula for variance? XR. This XR represent each data point, right? So this XR represent each data point, right? So XR is nothing but the first X1 is first data point, X2 is second data point, X3 is third, X4 is fourth, and X5 is fifth data point, right? See here, 2 minus mu. Mu is nothing but mean. So what is the mean? 8, right? So 8 and whole square, and this symbol summation is nothing but, this symbol summation is nothing but, yeah, so this symbol summation is nothing but you need to do it for all the data points, then sum those all the values. So that's what basically this summation represents. Okay, so 2 minus 8 whole square plus 5, this 5, oops, yeah, so this 5 minus 8 whole square plus 8 minus 8 whole square plus 10 minus 8 whole square and plus 15 minus 8 whole square, right? See guys, is this part clear, guys? Everyone from here to here, the highlighted one. So I'm just doing the I'm just calculating the difference from the actual data point to mean, and I'm squaring them up. I'm just doing square of it, right? Then divided by n, so I got 98 divided by 5, 98 divided by 5, right? So what is the variance, guys? What is the variance? 20. Guys, what is the variance? 20. Now see here, by looking at this variance, I cannot able to understand how strongly close or how far, how strongly away from the mean, right? So for that's the reason we do calculate the standard deviation, right? So basically standard deviation is nothing but, the square root version of it, the square root version of this variance, right? So whatever the variance I got, if I do see the symbol for standard deviation is sigma, right? So earlierly I do have this sigma square, but if I want sigma, I need to do square root on each side, right? Then my square and square root get cancelled, and the right hand side I will get the square, right? So inside that, this one, inside that the value of variance, which is 20, right? So what is the square root of 20, guys? It is 4.5. It is 4.5. So actually I missed out one thing. Yeah, so it was niche. Okay, so yeah, see guys, the standard deviation is 4.5. Guys, is this clear how to calculate variance in standard deviation? Just is this part clear? So that I'll move the next part, how you can actually this thing. So actually it will tell us the standard deviation is tell that the range of data points in one standard deviation, right? So yeah, so this is how you can calculate the variance and standard deviation. Just try to remember this formula, because we have an example, right? So these are my data points, and I have calculated mean for it. Then I'm calculating variance and as well as standard deviation, right? So mu is nothing but mean, right? See here, guys, just try to observe this particular the diagram, so which is normal distribution or Gaussian distribution. So see guys, this was my mean here, right? This was my mean, and this is from here to here, guys. Whatever the green color part that you can see with your eyes is called as one standard deviation from mean. One standard deviation of mean. Guys, is that my word clear, guys? Whatever the green part that you're seeing, is one standard deviation from mean. It could be negative side, or else it could be positive side. Just try to remember this word, one standard deviation from this particular mean, right? So what is the percentage of data points on left side of mean, guys? Left side of mean, what is the percentage of left side of mean? What is the percentage of data? What is the percentage of data in my green portion? In my green portion, what is the percentage of data on the left side of me? It is 34.1. What is the right side? Again, it is 34.1.
Equal.
Yeah. So if I sum this up,
Equal.
what will be the total number of data points? It is
68.
68.2, right? So when a data is normally distributed, and also called as Gaussian distributed, right? 68.2% of the data, consider 68% of the data lies within one standard deviation from mean. One standard deviation from mean. Okay, is this clear, guys? One standard deviation from mean. For example, you got mean here as 8. You got mean here as 8, right? So guys, for this particular data, you got mean as 8. Okay, you got mean as 8. Now just tell me, what is one standard deviation range, guys? What is one standard deviation range? What is one standard deviation range? Just
68.2.
no, I want points. See here, I do have this mean. I told you 68.2% of the data lies between one standard deviation, right? So left side you supposed to reduce, see guys, -1 standard deviation, this is plus side, and this is -2 standard deviation, and this is +2 standard deviation, right? So you do have mean here, and you also have standard deviation, right? So I want to find out the range of one standard deviation. Guys, what was that? On the left side, you're supposed to do -1 -1 standard deviation from the mean. -1 standard deviation from, what is the standard deviation here? What is the standard deviation? What is standard deviation?
4.5.
4.5. 8 minus 4.5, how much, guys? 8 minus 4.5, how much?
3.5.
Yes. So 3.5 to what is 8 plus 4.5? What is 8 plus 4.5?
12.5.
Yes, it was 12.5, right? See here, guys, as we have seen in the diagram, so this was a rule. It is just an assumption, guys, right? So basically the people, those who did lot many programs or lot many data science projects, they have come to a conclusion that, saying that, so 68%, if the data has normally distributed, right? So if the data has normally distributed, 68.2% of the data lies between one standard deviation of the range, right? So now, as you can observe the data, 68% of the data is lying between 3.5 to 12.5, 3.5 to 12.5, because that is one standard deviation. Now this thing, 95.4% of the data, 95.4% of the data lies lies within 2 standard deviation from the mean, right? So it could be negative and as well as it could be positive. Is it clear, guys? Is it clear? Everyone, is it clear?
Yes, clear.
68.2% of the data lies between 1 standard deviation and 95.4% of the data lies between 2 standard deviation. Now give me the range for 2 standard deviation. Give me range for two standard deviation, guys. Here, give me range
17.
for neg
3.5.
no 2 standard deviation. 2 standard. For 1 standard you have only subtracted you subtracted only 4.5 from 8, but when it comes to 2 standard deviation you need to multiply this with 2, because 2 standard deviation 2 times you need to come negative side, and as well as 2 times you need to go to positive side. So what is the 2 times of this one? It was, what is 2 times of 4.5?
9.
9.
9.
9 minus 8.
1.
Sorry,
1.
it is like 8 minus 1. 8 minus 9. That is
-1, sir.
minus 1 to
Minus
2 times.
17.
Yes, so 9 plus 8, 17. Right, see here. How much percentage the data was? It was 95% of the data. 95% of the data lies between 2 standard deviation from the mean. Right, so if the data got distributed normally, so here the data was not the data is not in a normal distributed way, so only we got in minus also, but no worries. So when the data is distributed in a normal way, that means there is no outliers. So even though there are outliers, that is not affecting the actual data point, right? So that is what exactly called as normally distribution, right? So just now we have seen example. So these are the basics thing, right? So 1 standard deviation negative side and as well as positive side, and 2 standard deviation from here to here, and 2 standard deviation from here to here. Is this diagram clear, guys? Everyone? Yeah, guys, is this diagram clear?
25% clear.
Yeah, so for 99.7% the data within 3 standard deviation, 3 standard deviation from the mean, right? So this what basically tells the normal distribution curve goes. Okay, so yeah, so that is the thing, guys. So it is also called as bell shaped curve, right? So it is like in the bell form, right? So the distributed is like symmetrical way from the mean, right? So yeah, what is example? Yeah, so this is basically just a example. So these are my data points, so from here to here, so these are my data points, and the mean is 20 and the standard deviation is 5, right? So I got mean as 20. Now the mean is 20 here, mean is 20 here. Now one standard deviation is 20 minus 5 to 20 plus 5, that is 15 to 25, right? So 15 to 25. And what is 2 standard deviation? So 20 minus 2 into 5, that is 10, that is 10 to 30. 10 to 30 is my 2
10 to
standard
30.
deviation rule. Guys, are you able to comprehend what I'm saying?
Yes, sir.
Yeah, guys, everyone, just
Yes.
okay. So yeah, so that's what we basically did that. Okay, so this is the formula for finding variance and standard deviation. Just standard deviation is nothing but the standardized version of variance. Just you need to do square root of it, square root of variance, square root of variance. Okay, so that's what basically standard deviation means. Okay, so it will tell how many standard deviation I should take in order to represent this much percent of data lies within this range, right? So for that's the reason you basically do the standard deviation and variance and all. Okay, so yeah, so the next part is covariance, guys. Just to try to remember this word, because we will going to use this variance and standard deviation and mean lot many times, because I'm just saying only the basic concept of statistics. So basically, maths for data science consisting of linear algebra, calculus, linear algebra, calculus, probability, and statistics. Right. So let me write it here. Oops. Yeah. So basically, let me write it here, guys. Yeah. So basically, maths for data science. Maths for data science consists of 4 parts, guys. So first one is linear algebra. Linear algebra, and the next one is, what is that, guys? Linear algebra, statistics, probability, and what is one more thing, guys? Linear algebra, statistics, and probability, and one more thing is calculus. Okay, so these are the 4 important topics for math for data science. So don't worry, so I'll definitely cover each and everything, but it's all up to you how you can able to do the beyond research rather than than my actual class. So it's all about understanding each and every concept. Okay, so calculus is also very important topic. So calculus and linear algebra and probability is very simple, and statistics we have completed almost like a few parts of statistics. Right, so statistics is basically we do some statistical kind of analysis on data to have some kind of opinion on data distribution. So that's what basically statistics. And probability is nothing but the chances of we make predictions on we make predictions on the data. Then by using some kind of statistical analysis, we will prove them. Probability is nothing but uncertainty, guys, whether that can occur or not. Right, so that is what basically a probability. And calculus is all about doing some we will have some just basic intuition of calculus for our syllabus. And linear algebra is all about where we have some kind of vector values, right? So matrix algebra and vector algebra and all this. Okay, so yeah, so I hope till this point is everyone having no doubt. Is it, guys? Does anyone have any doubts? Because we have covered only the basics things. Because I think in our school days we have already learned these things, right? So mean, median, mode, standard deviation, variance, and these things. And yeah, so let me complete this point within 20 minutes, guys. So covariance and correlation. So basically covariance is tell that, guys, I already taught you this concept, I guess, right? So covariance is nothing but the tendency in a linear relationship between the variables. So what do you mean by variables, guys? What is variable when it comes to data science? What is variables, guys? What is variable, guys?
Datas.
Where
No,
you
variables,
where you can store
that
data.
is the actual definition of variable. Think like a data science perspective. Variable is nothing but
Variable is
a
a column,
column.
a feature.
Yeah, feature. Excellent. So variable is nothing but a feature. There is a feature name and there are lot many hell values in that particular feature, right? So that is what basically. What is linear relationship, guys? Basically covariance tells the linear relationship between the data. What is mean by linear relationship? Linear relationship, if I change one value, how other value is getting changed? How other value is getting changed? Is this clear, guys? A linear relationship. See, I have taken that example. I don't know how many people were able to remember that example? So where I've taken some x values and as well as y. So y is a function. Basically, y is a function. Y is equal to 2x or 3x. Consider 2x. So so let me take x. Okay, so basically function f of x. Basically this was my function. F of x is equal to y is equal to 2x. So basically the function is also called as f of x. F of x nothing but basically we are finding y. With the help of this x, I'm finding y. So what is the function here, guys? What is the function? It was 2x, right? So let me take here as x values and y values. Now let me take x values as 1 comma 2 comma 3 comma 4 comma 5 comma 6. What will be my y values, guys? What will be my y values? So if x is equal to 1, what is my y value with the help of that
1.
function? Sorry?
No, 2.
Yeah, it was 2. Then if x is equal to 2, what is y?
4.
4. Then 3. Yeah,
6.
it was 2, 4, 6, 8,
8.
10
10.
and 12.
12.
Let's see here, guys. If I keep on increasing x values, my y also getting increase. My y also getting increase. So this is what exactly covariance tells us, right? So whether are they how they are correlated, how they are how they are correlated to each other, right? So what is the direction of my x values, guys? Is it positively increasing or else negatively increasing? X value, when it comes to x value,
Positively.
sorry, the y, see, yeah, it was increasing positively, right? So 1 2 2 is greater than 1, 3 is greater than 2, so it is positively getting increased, right? So if I increase my x values, my y also getting increased because y value depends on x value. Yes, absolutely. So here my y value is depending on x because that is what the ultimate thing we are finding here, right? So if I keep on increasing my x value, the y also getting increased only, right? So with x value, with the increase in x values, y value is getting increased. So that is what exactly called as positively correlated. So I don't know how many of you are able to remember that part. So positively correlated, negatively correlated, like that, right? So on that day I've given this kind of intuition for relationship. So where I've taken one function like this, then I shown you an example. Okay, see guys, when the variable tend to show the opposite behavior, see, when the variable tend to show the similar behavior, then the covariance is positive. Tell me what is the covariance here? Is it negatively or positively?
Positive, sir.
Yes, it was positive because if I increase, other also getting increased, right? So if I increase one value, if I increase x, if the y value is getting decreased, if the y value is getting decreased, so that is called as negatively covariance or negatively correlated. Okay, so the covariance correlation both are same, guys. Covariance is just tells whether are they positively covariance or negatively covariance. But what is correlation tells us is it will give some exact figure or exact number, the exact number from +1 to -1, so that with the range of +1 to -1, we can understand how strongly they are correlated or how weakly they are correlated, or else how moderately correlated are those variables are. Okay, is this clear, guys? Guys, is this clear, everyone? The covariance and this thing. So it just covariance tells us whether that is positive or negative, right? So Yeah, see, the examples are, see, when I increase my quantity, the price also get increased, right? So for example, if you go to a supermarket or any shop, if you buy one product, the cost is around like 10. So if you add two quantity, then the price will become 20, right? So the quantity and price. And negatively correlated, the examples for negatively correlated is, in cricket. So in cricket, when the current run rate is high, when chasing was happening, right? So I hope everyone know cricket thing, right? So when chasing thing is happening, right? So if their current run rate is high, then obviously required run rate will get low, right? So let me take this example. So when you see guys, for example, if I book ticket, I want to fly to America from India, right? So I want to book ticket exactly tomorrow. So tomorrow I have to tomorrow I have to go to America, right? So that I want to book tickets. Will the price is less or more compared to actual price, guys? Will the price will be less or high compared to actual price? Guys, are you able to understand my question? So basically what I want to say is, the gap, the time between the actual departure time and as well as the current booking time was very low, right? So if I want to book flight exactly for tomorrow, the price will be obviously high, right? So in the second case, I want to book a flight on after 1 month. I want to book flight after 1 month. Will the price will be low or high, guys? If I book for now, I'm booking and the departure time is after 1 month.
It's going to be
Basically
low.
now I'm
It will be low.
yeah, so it will obviously low. So I think you got the idea, right? So when the departure, the time between the booking time and the departure time is less, then the ticket price will be high. When the time between the booking time and as well as departure time is very high, then the price will be low. So that's what I exactly want to say, right? So time for booking is more, then the price will be low. If the time for booking is low, now I'm booking the flight and tomorrow is my departure date, then the price will be obviously high. So that's what basically the flight tickets gonna work, right? So the next thing is correlation, right? So correlation will give you the exact figure how the values are correlated. See guys, let me give you these points. See, when the correlation value, see guys, this is what exactly how you can find out the correlation value. So there is one coefficient where you can find out the correlation, that is called as Pearson correlation coefficient, right? So this is how you can calculate that. So covariance is the formula for covariance is this one, x minus mean of x into y minus mean of y divided by n minus 1. Is this clear, guys? This formula, basically, if these are my data points, so yeah, so if these are my data point, no, this one, so let me take the list data points. Yeah, so let me take, these are my data points. Okay, sorry, I supposed to have two data points, right? So yeah, so if x and y are data points, let me copy these things. Yeah, see guys, so if these are my data points, so I have to calculate mean for it, right? So then mean of x and as well as the mean of y, right? So then you know how to differentiate these things, right? So the covariance is this sum is nothing but we need to make addition of all values. That 1 minus what is mean of x? 1 minus mean of x into 2 minus mean of y plus 2 minus mean of x, 2 minus mean of x into 4 minus mean of y plus 3 minus mean of x into 6 minus mean of y, so on so forth, divided by how many data points were there, guys? 1 2 3 4 5 6, right? So 6 minus 1, how many, guys? 5. Is this clear, guys, how you can actually calculate variance, covariance? Sorry guys, this is not variance, it is covariance, don't get confused. Is this clear, guys, everyone? Yeah, so just give a try, guys. You'll there is nothing beyond that. And this is how you can actually calculate the correlation coefficient, where covariance of x comma y divided by standard deviation of x into standard deviation of y, right? So you know how to calculate standard deviation, is it, guys? Do you all know how to calculate standard deviation of one variable? Guys, you all know how to calculate standard deviation of x variable and y variable?
Yes, sir.
Yeah, so you have formula, right? So standard deviation nothing but square root of variance. You know how to calculate variance, right? So these are the examples, guys. Just try out, then you'll definitely understand. Okay, so yeah, so that is what basically the thing, correlation. And if the correlation is, yeah, see here, if the correlation you got is minus 0.7, guys, tell me the correlation. So whatever the r value you are finding for these two xy, for these two xy, your r value is minus 0.7. Tell me whether is it negative, positively correlated or negatively correlated, or okay. So here itself, see, guys, if the value was negative, if the values were negative, is it positive or negative, guys? Is it positive or negative if the values are negative? Guys, are you able to understand what I'm saying? Guys, am I audible?
Yes, sir, you are.
Yeah, then I was unable to get any kind of response from you.
Because I guess everyone are confused.
Okay. Is it, guys? Is this topics are getting confusing, guys? Everyone? No, right? So yeah, see, guys, if the correlation value is like this in the negative, then obviously it's negatively correlated, right? So if I increase values in x, then obviously a y value will get decreased. We can observe the, yeah, so yeah, see here, guys, if my x value between 0.7 to minus 1 to minus 0.7, and as well as and as well as and as well as +1 to 0.7, right? So is this person as Shadrak, what was that? I didn't. Shadrak, what was your question? Can you come again, please? See, guys, if my correlation value if my correlation file, let me take it as R instead of X. Let me take it as R so that you can able to understand. So are we calculating correlation or coefficient? Yeah, correlation coefficient is nothing but that thing only, right? So to represent correlation coefficient is nothing but what, guys? Coefficient is nothing but just a value, right? Coefficient is nothing but just a value. So basically I'm finding I'm basically finding whether how my how my values are related to each other. If I increase one value, how it is getting affected to other value, right? So that's what basically I just want to find out, right? So if r if r is between r in between -1 to -0.7, then it is strongly there is a strong relationship between the data, right? So there is a strong relationship between X and Y. That means if it is in negative, then it is strongly negatively correlated. If it was +1 to 0.7, then guys, so yeah guys, see, if my R value, if my okay, so not necessarily the correlation coefficient. Okay, basically guys, what do you mean by correlation is, see, covariance is just tells us are they positively correlated or else negatively correlated. That's what basically covariance tells us, right? So when you have a data, when you have a dependent variable and as well as independent variable, right? So see guys, in this case, okay, so in this case, what is a dependent variable and what is independent variable, guys? In this case, what is dependent and what is independent, guys, quickly? In this case, what is dependent variable and independent variable?
X is the dependent variable.
Independent variables are variable that does not have relationship.
Yeah.
Why dependent is
Yeah.
variables that has
Basically,
relationship between them.
I'm finding y based on one function which is f of x. What is f of x? F of x is equal to 2. So it's better to write y. Y is equal to, I'm finding actually y value based on some function. What is a function? What is a function? F of x is equal to 2x, sorry, right? So if I substitute in the place of x, if I substitute 1, what will be my y? If I substitute 2, what will be my y? If I substitute 3, what will be my y? So based on this function is 2x here. Now here x is my independent variable, but y is depending on x. Y is depending on x, right? Basically, with the help of this covariance, I want to find out how actually the dependency is occurring. Are they negatively relationship, right? So if I keep on increase, if I substitute some values for x, if I substitute some kind of pattern value, see here, what you can observe the pattern in this x values, guys. What you can observe the pattern in the x values, guys. What is the
Increasing
pattern in this?
in the,
Yeah, increasing by 1, right? So 1 2
yeah,
3 4, right? It is increasing by 1. If I have increasing of 1 in my x, how my y values are, Now in this y, what is the pattern, guys? What is the pattern? Guys,
Increasing by 2.
yeah, increasing by 2, right? So if I increase only 1, if I increase only y in my x, I got 2 increment in y, right? So this is what exactly I want to find out, whether they are strongly correlated or whether they are weakly correlated. Let me take, instead of 2x, let me take x only. Now if I have x, just tell me what is the correlation for x and y, guys? If I have function x, if I have function f of x is equal to x,
They are,
what is the correlation between x and y?
they are similar.
They are similar in nothing but, of course they are similar, but tell me in the this thing strongly, a Pallavi. See, if I observe some positive trend, I would have tell you the positive relationship. But if I have negative values trend, then I would have tell you negative. The values are same. If I substitute in the place of x, if I substitute 1 to 3, the y values also
Maybe
y values are also same. How, what is the covariance over there? Weakly, yeah. Can you find a correlation
weekly.
over there?
Okay.
First of all, can you find can you find any correlation? If you substitute x, if you substitute 1 for x, what is the y? 1 only. There is no correlation at all, guys. There is no correlation at all. Are you able to understand, guys? Everyone, guys, is this topics are confusing, guys? Just the simple topics. Okay, guys, I think there was some kind of the how can I say? Yeah, so I think my explanation was not up to the mark, because actually I am suffering from fever right now. So only I was unable to explain each and every concept here, but these are just simple topics, guys. I don't know why you are getting so confusing for these topics. Okay, so yeah, covariance is just to tell us how their values are, whether they are positively correlated or negatively correlated, right? So correlation is nothing but, if you increase one, how others are getting affected, right? So if you decrease one, how other how other values getting affected. So that's what basically the correlation is, right? So covariance is just tell us whether they're positive, negative, or moderative, or no covariance at all, right? So but correlation, let us solve a question on it. Yeah, so that would give you a better help. Okay, so okay, okay, guys, I want you solve it from you only. Just ready with your pen and paper. So it is 6:41. The time, we still with 20 minutes left. So I'll just finish it off 5 minutes. Then after 5 minutes, you have to solve. So I'll tell you, because guys, I'm really, basically I was as I told you, I got fever. So I don't want to make a huge gap in the classes, so only I'm conducting today class. So yeah, I'll do one thing. So just okay, okay, is this values are clear, guys? Just let me tell you, let me know, is this values are clear? 1 2 3, and I got, with the help of this particular function, 2x, I got this thing, right? So now find the mean for it. Find out the mean. Find out the mean, guys. Quickly tell me, find out the mean. Mean for x and mean for y. Quickly, guys. You have to do it quickly. I'll tell you the procedures for you people. Yeah, so mean of x is 3.5. Now, what is the mean of y? What is the mean of y? What is the mean of y? Is it 7? Okay, fine. Okay. Hey, 5.3. Guys, what is the mean of y? Quickly, guys. Fatima, are you doing? Yeah, so 7, right? So 7. Okay, fine. Yeah. Now, covariance formula is this one. Covariance formula is sum of x minus. Okay, so guys, give me a second, guys. I better to draw it from here. That will definitely help me and as well as you. So 1 2 3 4 5 2 6 7. Okay, so let me do that here. So what happened? I'm not sure how many values were there. Guys, just give me a second. Yeah, so this was my x and this was my y, right? So for x, 1 2 3 4 4. Wait a second, guys. 4 6, and there 2x is 2 4 6 8 10 12. Now mean of x and mean of y. Okay, so what is mean of x? 3.5. I just want. Okay, is equal to average from here to here. Enter. Yeah, it was 3.5. And the mean of y is equal to average. Yeah, average. Yeah, so now average of y is 7. Okay. Okay, fine. So now covariance, guys, how you can actually find covariance for it? Covariance. What is the formula for covariance? Formula for covariance is sum of x minus mean of x into y minus mean of y. Okay, so you got. Okay, so I'll do one thing. X. Okay, I can do this. No need. Ayo. Oops. Okay, fine. So yeah. Guys, give me a second. Yeah, fine. So let me draw it for all. This thing, Control D. Hey, what happened? Why it was like that? 3.5. It should be same, right? Again. Okay, fine. Guys, actually that was Google Sheet. I don't know why I was. Okay, so mean of y is 7, 7, 7, 7, 7. Okay, so yeah. So this mean of x and mean of y. So now xi minus mean of x. Guys, x of I minus mean of x. That means 1 minus 3.5, 2 minus 3.5, 3 minus 3.5, and 4 minus 4.5. Is it clear, guys, everyone?
Yes.
Yeah. So you can do 1 minus 3.5. How can I do that? So is equal to subtract difference. What is that? Okay, so okay, so guys, can you solve this one? Just the difference from mean to the difference from actual points to the mean. That is 1 minus 3.5. 1 minus 3.5. What is the value of 1 minus 3.5, guys? It is 2.5, guys. Minus 3.5. Minus 2.5. Yeah. So for 2 minus 3.5, guys, it is minus 1.5. Next, this one, guys,
minus 0.5.
it is in minus. Yes, it was in minus.
Yes.
Yeah, so thanks, Franklin. So 0.5, then 0. Is it 0? Yeah, so it is
There are not
positive 0.5, and the
0.5.
next one is
Yes.
1.5.
1.5.
Next is 2.5. Thanks. And same, guys, yi minus mean of y. Quickly, guys, yi minus mean of y.
Minus 5.
That means 2 minus 7, 5. Okay, 5. Then here
Minus 5.
3.
No, it's fine. It's fine. Sorry.
Yeah, it was 3, right?
Yes.
Next,
3.
6
1.
minus. Guys, I
1.
think it was in negative, guys. Minus 5, minus
Yes.
3, and here minus 1. Next, guys, quickly, guys, try out solve on your notes. You know, if you solve on your notes, then it will be quite easy for me.
It's 1. 1.
It was positive 1, right? Next,
3.
3. Next,
5.
5.
Yeah. So now, next covariance from is x minus mean of x into y minus mean of x, right? So yeah, so we need to do product of these two, x minus mean of x, y minus mean of y, right? So product of this one, this two. So let me write it as product, guys, instead of all this product. Okay, yeah. So let me do multiplication. Multiply. Oh my god, I got multiply of this one and this one. Okay. Yes. Hey. Oh my god, what happened? Is equal to mul. Is it jth column? 20. Yes. And this also. I think I can drag like this. Yeah, fine. So product is this one. Now, guys, are you able to understand what I'm doing?
Yes.
So now, what is the summation, guys? Sum of all these values? Sum of all this?
Total of product.
Yeah, so is equal to sum of, yes, it is 35. Now, standard deviation of x. How you can actually find the standard deviation, guys? Before going to standard deviation, we need to find what, guys? We need to find variance. How you can actually find
Variance.
variance, guys? See, this was the thing, right? So we need to do square of it. We need to do square, then summation. Is it, guys?
Yes.
Yeah, basically, this variance is, oh my gosh. Yeah, so this one, 0 minus 50 whole square plus 50 minus 50, right? So this was a summation divided by n, right? So we have to do that, right? So let me do it. So this thing, the square of all this, right? So let me do that here. Copy, paste. Let me take it as square, right? So power square, and for this also copy, paste. Guys, I'm sorry, I'm making much delay because I don't have that uh, that pad. I can reach out. So yeah, so how you can actually do square is equal to square. No, I do square. So square is nothing but multiply only, guys. Multiply of this thing and comma this thing. Okay, so it is 6.25, right? So let me do it for all. Yeah, so it was this thing. Is it clear, guys? And also for this y also is equal to multiply of this one comma this one, same thing. Enter. I got 25, and let me do it for all, right? So it is this one, and the summation of this thing, the entire summation is equal to sum of, yeah, I got it is 7.5, and here is equal to sum of, I got 70. Now standard deviation square root of this thing is equal to SQ RT of this one. Enter. So it is 4.18, and the standard deviation of this one is equal to square root of, yeah, it was guys, I'm actually doing lot many things, but basically you do have this standard deviation function, I guess. STD. Oh no, standard deviation, there is a function in Excel, standard deviation. So if I just do, let me do it here, is equal to standard deviation. There is a function which is standard deviation of from here to here, same thing. 1. Oh, I got 1.87, but here, okay, I did a mistake, guys. I don't know where I did mistake. So standard deviation is this one, is equal to STD standard dev. Yeah, so if I execute, it was 3.7. I did a mistake. I don't know where I did mistake. Okay, so let me check variance. So variance of from here to here. From here to here. Okay. Here. It is E24. So it is 3.5. I got variance around like, I don't know. So let me do that, guys. So variance is equal to variance. Same thing. So it is 14. Right. See, guys. The standard deviation for X variables, I got 1.87. For standard deviation of Y, I got 3.7. Right. So the covariance formula is, I think, up to 35, 75 clear, I guess. Sorry. The product, this one, 35. And have to divide. Okay. So yeah, guys, basically this is also fine. Square root of it. Basically, I need to divide it by how many data points were there. Yeah, so I
6
missed that.
-1.
Yeah, basically this is also fine, guys. Whatever the process that I'm basically for standard deviation we need to divide by n, right? So the square root of this thing divided by n. So basically I have to do here. So here, whatever the sum I got, I have to divide it by that one, divided by n. N means total number of points. So 1, 2, 3, 4, 5, 6. So I have to divide it by 6. Right. So let me do that here. L2 divided by 6. Yeah, it was 2.99. Then I can do SQRT, this one, square root of this one. Now it was 1.70. So both hardly same there are, right? So 1.87 and 1.7. Right. So yeah, I think where we are here. Yeah, standard deviation we got. Right. So what is this one? The formula is for covariance of x comma y and standard deviation of x and standard deviation of y. So what is covariance of x comma y, guys? So the covariance is for this thing. So this covariance formula is this one, the product 35, right? So basically the covariance formula is this one, sum of x minus mean of x into y minus mean of y divided by n minus 1, right? So what is n, guys, in this case? What is n? 6. So 35 divided by how much, guys? 35 divided by n minus 1. 6 minus 1, 5. So basically I got 7, right? So covariance I got, the covariance is 7 divided by standard deviation of this thing and as well as this thing. So is equal to 7 divided by bracket 1.87 1.87 into 1.87 into 3.74. I don't know how much I'll get. Yeah. So guys, actually I supposed to get up to one only. So the value shouldn't exceed more than 1. But here I got basically some, I don't know where I did mistake. So only I got 1.0088. So this 88 shouldn't be there because the correlation value always between +1 to -1. right? So there shouldn't be a value beyond that range, right? So correlation factor or correlation value will be always between +1 to -1. It could be +1, all those things. Yeah, so up to, no, you can even equal to 1 also, but it shouldn't exceed 1, right? So is this value greater than 1, guys? Is this value greater than 1?
Yes.
Yes. So you shouldn't get a value like this, because it always between equal to 1 or else less than 1, and equal to -1 or greater than -1. That's it, right? So it shouldn't exclude -1.01 or like that, right? So and even 1.0 like this. So see here, guys, consider this is 1.00 only. So instead of remove this 8, let me remove this. So let me remove this 8864 So consider, guys, how they are correlated. I got the value. Guys, I got the value as this 1.008. So consider this. Remove this. Only consider this is 1 only. So how they are correlated, guys? If the value is 1, how they are correlating? What is the meaning of it? If the correlation factor is 1, correlation coefficient is 1. How they are? How these values are x and y? How these x and y?
1 by 1.
No, just give me the meaning. How it is like, see. Yeah, based on this this format. So is it positive or negative, guys? 1
Positive.
positive, right? So the correlation factor, we have ranged the correlation factor from -1 to 0, then 0 to +1, right? So if the correlation factor is -1 or close to -1, then it is strongly negatively correlated, right? So if the correlation factor is +1 or very close to +1, then it is strongly positively correlated. If the correlation factor is 0, then there is no correlation, and if the correlation value is close to 0, then there also there is the weakly positive and as well as weakly negative. Now based on that scenario, you got one here for this case. Now tell me how the correlation was, how the covariance was. Is it positively, negatively, positively strongly, or negatively strongly, or moderate or weakly positively, or weakly negatively? How this was? I got one.
Strongly positive.
Yes, absolutely. So strongly positively correlated. That means, see, if I keep on increasing x value, my y value is absolutely getting increased. So strongly positively correlated. If I got 1, if I got correlation value as 0, what do you mean, guys? If I got correlation value as 0,
Strongly negative.
sorry,
Strongly negative. Oh, no.
if I got the correlation value as 0, no correlation at all, no covariance at all.
Yes,
Consider the
yes.
case. Consider this case. In the case of function x only, no correlation only, right? So now I got 0.5. I got correlation factor as 0.5. Tell me. Guys, I got 0.5. Guys, I got 0.5. Guys, If 1 is strong, what is 0.5 then? If 1 is strong, what is 0.5? Guys, are you all here? Not even weak. Yeah, it is like moderate to correlation. Not we cannot say weak, but moderate correlation. If the value is somewhere around like 0.2, if the value is 0.2, now this case 0.2, now we can say weakly correlation. Weakly in a sense, is it positive or negative, guys? 0.2 weakly positive, right? So if I have minus 0.2 weakly, the value is less. 0.2 is very close to 0, right? So weakly negative, right? So
Weakly
if I have minus 1, what do you mean by minus 1?
strongly negative.
Strongly negatively. Is it clear, guys? Now you got idea. If we the correlation values and as well as how the correlation within the data. Yes, right. So if it is even minus 0.5 also, minus 0.9 also, we can think it is strongly correlated, strongly negatively correlated, because this minus 0.9 is very near to minus 1, right? So we can think it is strongly negatively correlated only. So if it is minus 0.8 also, strongly negatively correlated, right? So that was the map here, right? That is what exactly the map here, right? So if the R value is in between minus 1 to minus 0.7, if I got any value of R between minus 1 to minus 0.7, then it is strongly negatively correlation. If I got R value as plus 0.7 to 1, between the range of plus 0.7 to 1, it is strongly positively a relationship or correlated, right? So yeah, so if it is less than 0.7, then it is positively, not even strong, guys, it is moderative, just positively moderately correlated. Oh yo, okay, this is one meaning, guys. This is entirely one meaning. If it is greater than 0.7, we can think of positively strongly correlated. If it is minus 0.7, then negatively strongly correlated. See, the ranges are like this. Is this clear, guys? Just replace it R. Don't take it as X. It is supposed to be R. Is this clear, guys? This concept, this one?
Yes, it's clear.
Yeah. So that is what, guys. Just read you itself and you will definitely understand. Yeah. So if it is R is equal to 0, then there is no correlation at all. Right. So yeah. So covariation, see, the difference is measure the indication extent, how much, whether it is positive or negative correlation. But correlation gives us exact figure between range of minus 1 to plus 1, right? So that is what, see, guys, if I say there is a positive relationship, then you cannot understand how strongly they are correlated. But if I give you an exact figure, so it is minus 0.9 correlated, that means if I there is strongly negative correlation. See, guys, 0.4 the data looks like, right? If I keep on increasing my x values, y values get increased. See, now consider this point. So this is this one and this one, right? So this is a map for this. So if there is no correlation, the correlation factor will be 0, right? So if it is negative correlation, you will get the negative as in the minus form. Is it clear, guys, everyone? Guys, everyone, is this clear? Just yeah. So yeah, fine, guys. I hope you all understood today's concept, even though it is a little confused. Guys, I don't know how you can able to understand even the core part of maths. See, this is consider where I've indicated those things. Yeah. See guys, when we deep dive into actual math concepts for data science, there will be derivative, there will be integration, there will be so many things guys, different kinds of distributions of data, right? So like normal distribution, binomial distribution, your continuous, when it comes to probability, there are random variables, discrete random variables. I don't know how you can able to understand all those things, but this is what are the concept that I taught today is the complexity level of these concepts are 0.01. Just think yourself how the other topics will be guys. I don't want to see, I'm here to sort each and every concept in a clear cut manner to you, but the main thing is you need to supposed to be very focused and intuitive. Okay guys, does anyone have any doubts for today's class? Guys, does
It's
anyone
clear
have? Yeah, so
for me.
yeah guys, I'm really thankful to you all because you had a great patience, because even though as I told you, I'm suffering with fevers, so even though my explanation was little not up to the mark, then you had all stayed with me until last, so that's really wonderful guys. Yeah, Shadrach, make sure that you should have. So yeah guys, so that's all for today, so we'll see yeah, so we'll see tomorrow guys with few more new concepts, right? So where I can teach you something called as normalization, I guess. Yeah, so yeah, that's all guys, we'll see tomorrow, so until then, take care, bye bye, and once again thank you all. Take care guys.
Thank you so much. Bye bye.
Yeah guys, thanks a lot, bye bye guys.